Great. Okay, so Lab 3 in C++. So far, what we have learned to do is only really spitting stuff out to the screen. Okay, that has been the goal so far for the first 2 days. Basically using this command, which is called cout. It's pronounced cout. And you can write words to the screen by putting them in quotes. Goodbye. This little end L thing will skip to the next line. You can make it do math. 4 plus 9, it will do math. You can make it do both, but you just have to go goodbye, boom, boom, and then 4 plus 9, and it'll do both like that. Okay, so that's what we've learned so far in a nutshell. A little bit more complicated than that, but we don't need to go over it all right now. Okay, I'm going to run it. You'll see that it'll say goodbye, and it'll say, am I running from my X drive? Yeah. First time you run from the X drive during the day, typically pretty slow little process there. Why is it so slow? I don't know. Oh, it went there. Just let it go. Let it think. I know a lot of people are freezing their computer, and I bet it's because they're probably like pressing a billion buttons while it's loading. Okay. Impatient. There you go. Goodbye, goodbye, 13. That's kind of essentially what we've learned. We've also learned that you can store numbers in the computer, but we've only learned how to store whole numbers, integers. Okay. So num1. I could make a num2 as well. I could set them equal to things. Okay. I could even set them not equal to things, and you would see. Okay. Num1 is now kind of treated like the number 16. Okay, it went into the memory of the computer, found the place where it was located, saw that 16 was there, and it will write it down as 16. Num2 is anybody's guess because I didn't set it equal to anything. So when I run that, it put 16 and 6,422,348. Yours will be different. Okay? That's how we store numbers in the computer. Whole numbers. Today we're going to learn how to store decimal numbers. For now, we'll just use the word float. I'm making num3. Okay? Stores decimal. What you probably saw when you were dealing only with integers in Lab 2 is that when you do math with them and you're expecting decimals back, you're only going to get integers back. Has to do with the way computers store your information. It's much easier for a computer to deal with integers than it is with floats. So if you start giving it all integer numbers, it will just do everything with integers and cut off any decimals. Floats, you end up losing some precision on how accurate your decimal numbers could be, just because of the way the computer converts your number to ones and zeros and then converts it back. But they're very useful. They're what you use most often in your code, and they will hold decimal numbers like this, 3.5. Okay? Can you times an integer by a float? Let me see out num3 and see what it says first of all. It should say 3.5. Okay? Great. It says 3.5 on the screen, so that is working as expected. And you can have any number of decimals that you would like, totally fine. Could you take a float and times it by an int? Yeah, C++ is okay with that. Num1 times 3.5, or times num3. That should spit out, what's num1? Num1 is 16, and num3 is 3.5, so it should do the math there, and it'll actually spit out a decimal. As long as there's one decimal involved, one float number, it'll make sure everything's in decimals for you. So, does it? Yeah, 3.5 times 16 apparently is 56, which is actually an integer. But let's say I make it 3.51, just to test to see if it's going to spit out a decimal for me. And it does. It spits out 56.16. So that is how you deal with decimal numbers. You just have to there's just, you know, the only thing you really have to do is write the word float in front of your variable name instead of integer. What are some of the other things the lab asks? One of the other things the lab wants you to do is make a variable that's called of type character. This is a variable that's used very infrequently in C++. I'm just going to call this one letter 1. It only holds one letter, so it's kind of useless for the most part for us, for the stuff we'll be making. And the other awkward thing about it is it needs the letter in single quotes and not double quotes, like the words that we've been putting on the screen using cout. So that is awkward, but it's okay. We can do it. And then we can cout letter. Kind of useful if you're looking at keyboard presses later on. You want to see like what keyboard letter or keyboard button was pressed. But we won't even use it for that later on. We have a better way to deal with keyboard presses. But there you go. It says the letter A on the screen. Can you set a character variable equal to a whole word? I think it'll probably let you, but then just screw up somewhere along the line. It just wrote the letter D, so it must just take the last letter of the word you put in. So not a great idea to do that. Could definitely cause some bugs along the way. Yeah, later on we're going to use them as numbers. So because the computer doesn't know what the heck letters are, right? This thing actually stores it as a number. So you could let this letter equal a number between 0 and 255, and when you output it, it'll spit out a letter. And it gets it from this table called an ASCII table. So I'll show you what that is in a second here. If I run that, I wrote 87 and put a capital W. Okay? W. Well, that might be a little W, I'm not sure. But you can convert back and forth between types in C++ and it won't complain. It doesn't care if you give it a letter or a number. It'll just convert it how it sees fit. So if you want to see what each letter represents as a number in computer programming, you go and look at something called an ASCII table. It's right here. Just pick one. They're all the same. I like this one, actually. Let's look. Rapidtables.com. Actually, there's too many. I need a little bit better of a description here. So I'm gonna pick this one here, ASCII table. I can't remember what ASCII stands for. It's like an old school acronym for something to do with DOS or something like that. So let's click on that. The Wikipedia one. Is there? If I go to number 87 on this table, what is it? A W. There you go. And there's all kinds of. This one is only 0 to 128. They actually should go to 0 to 250. Let's find a really crazy symbol that you would never use. And we'll see if we can get it written on the monitor. And then you can see how they'll make a game like, what's that, like, typing game that everyone used to play? It's called, like, Orcs or something. What is that game? It's like a huge game. It's called, like, Orcs or something. They're turning it into an actual... No, it's not World of Warcraft. It's a typing game. It's like a DOS game. DOS game. Orcs. Orcs and humans? Is that it? No, that's the very first Warcraft. DOS game. I can't remember what it's called. Anyways. It's like, I don't know. You just like build bases and stuff. It's like goblins. Alright, hold on one sec. I'm going to get the computer to print out the square root symbol, which is 251. Your computer crashed? Okay, I'll come and fix it in a second. What did I say the square root button was? My computer crashed. No, it's going okay. It's fine. How come mine never crashes and you guys always crash? Wonder if I got the better computer. I wrote 251. Is that the square root symbol? Yeah. Look at that. Amazing, eh? Yeah, so you can convert back and forth. Here's a cool thing you can do. You could get it to write. Okay, let's say I want 251 to be written on the screen. Okay. And so I wrote the number 251. But let's say I want it written as a character in C++. If you ever want to convert any type of variable, you just write the type you want it to convert to in brackets in front. And that will convert to a character variable. So that will actually convert the number 251 to the square root sign. Okay? You could do it with decimals too. See how it's a square root sign now? You can do it with decimals too. Like let's say you're not going to round the number, but let's say you just want to chop off any decimals. You write the word int in front of some number you have, or perhaps a variable that has decimals. That will write the number 2 on the screen, because it'll chop off the 0.76. Let's see if it does it. It does. So you can convert back and forth between the 3 types we know so far, which are integers, floats, and chars, which stand for characters. Okay? So that's another good thing to know about Lab 3. Is there anything else? There's a few little tricky questions in there, but we'll figure them out as we go along. I think the new line character, which makes your text go to a new line, is in that table somewhere. I think it's line number 10. What's 10? What's my ASCII table? That wasn't a very good ASCII table. I think I like this one the best. I need one that goes from, let's have a look. It's new line feed. A lot of these names are based on old typewriters. Look at this. Bell. Okay, we don't have a bell on a computer anymore. A carriage feed, a form feed, a vertical tab. These are all things you used to do on a typewriter. Okay. 10 is the line feed, which makes it go to a new line. Okay. All of these are based on old typewriter buttons. Kind of cool. Little blast from the past there. Okay. So have a look at Lab 3. Try Lab 3. I'll be around. Ask your neighbor if they're ahead of you. I'll post this video to YouTube as well.